Hi, this is Dr. Neil Alexis from UNC Chapel Hill. This video is going to demonstrate the steps of the sputum processing technique for Spiromics 2 samples. To begin with, sputum samples will be processed according to the initial weight of the induced sample and whether a spontaneous sample was acquired prior to the induction. There are 5 conditions to consider based on these 2 parameters. Condition 1, you have greater than 1 gram of induced sample. Condition 2, you have between a half a gram and 1 gram of induced sample. Condition 3, you have less than a half a gram of induced sample. Condition 4, you have less than a half a gram of the induced sample and there is spontaneous sample. Condition 5, you have no induced sample but there is a spontaneous sample. If you have condition 5, there are 3 subconditions to that. Condition A, you have greater than 1 gram of spontaneous sample. Condition B, between a half a gram and a gram of spontaneous sample. And condition C, half a gram of spontaneous sample. The first step on your processing worksheet is 7.1.1, weighing the sputum sample. First, pour the entire sample into a petri dish and begin to record its characteristics, such as color, consistency, the presence of saliva, the presence of plug material. Before weighing the sample, if there is obvious clear saliva that can run to the side of the petri dish, take a pipette and remove that saliva from the sample. This we can call saliva avoidance, but note, it is not plug selection. Weigh an empty 50 ml tube with its lid and record the weight on the tube. Zero the balance or the scale. Next, pour the entire sample into the 50 ml test tube. Measure the weight of the sample on your scale. Once you determine the weight, put the sample back in the ice bucket. Now that you've determined the weight of the sample, we're going to begin the first endpoint, which is processing for mucins, 7.1.2 on your worksheet. Weigh an empty microcentrifuge tube and record the weight on the worksheet. Next, zero the balance. Next, acquire between 0.1 grams to 0.25 grams of sample. And deliver it into the microcentrifuge tube. Next, record the weight on the scale. Next, add a half a ml of 6 molar guanidine reduction buffer to the sample. Then mix the sample by tipping the tube back and forth manually. Once you finish that, the sample is ready to be stored at 2 to 8 degrees Celsius. The next step is from the remaining sample, we're going to process for the microbiology endpoint. First, weigh an empty microcentrifuge tube on the scale. Next, zero the balance. From the remaining sample in the tube, acquire 0.2 grams of sample and record the weight. Weigh the sample so you have approximately 0.2 grams. Next, add 200 microliters of Zymo Research RNA DNA Shield to the sample and mix it. Next, divide the sample into 2 equal aliquots, 100 microliters each. So far, we've processed the sample for the mucin endpoint and the microbiology endpoint. The sputum worksheet will look something like this with its values recorded in sections 7 and 8. The sample is stored in the -80-degree freezer. The next step is processing for percent solids or osmotic pressure. Weigh an empty microcentrifuge tube and record this weight on the worksheet. Next, zero the balance. From the remaining sample, try and obtain a minimum of 0.05 grams of sample. The easiest way to do this is to use a 200 microliter air displacement pipette and draw up whatever can be achieved. The exact volume isn't important, but using a 200 microliter pipette will ensure that anywhere between 0.05 and 0.2 grams will be captured. Once you've done that, deliver the sample into an Eppendorf tube, which will be stored at -80 degrees Celsius. Record the weight of the sample on the worksheet. Store the sample for percent solids and osmotic pressure at -80 degrees Celsius. The next step is to process the remaining sample for cytokines, nucleotides, cell counts, cytospins, and RNA. First, weigh an empty 50 ml conical test tube. Next, zero the balance. Next, add the remaining sample to the 50 ml conical test tube and record its weight on the tube. Next, add 8 times the sample weight of cold EDTA DPBS buffer solution to the sample. Homogenize the sample for 15 minutes on a rotating tumbler. Once the sample is finished on the rotating tumbler, it is centrifuged at 790 G for 10 minutes. After the sample is removed from the centrifuge, remove half the volume of supernatant and dispense that into a separate tube. The removed supernatant is returned to the centrifuge. The settings are 1500 G for 10 minutes. Once the sample is removed from the centrifuge, the supernatant of that sample is removed and put into a separate test tube. That sample is stored at -80 degrees Celsius. If the sample volume is greater than 8.6 mLs, which it is in this example, obtain 4 1000 microliter aliquots for nucleotides, 4 1000 microliter aliquots for cytokines. Of the remaining sample, take 600 microliters and mix it with 600 microliters of Zymo Research RNA-DNA Shield. If the sample volume is less than 8.6 mLs, you can start by getting one nucleotide sample between 200 and 500 microliters and one cytokine sample at 200 microliters. Mix one of the cytokine aliquots 1:1 with the Zymo Research RNA-DNA Shield and label it. If there is any sample left over after this, you can continue alternating between nucleotide and cytokine aliquots. The nucleotides 200 to 500 microliters, the cytokines 200 microliters until you're finished. Store all of these supernatant aliquots immediately at -80 degrees C. To the master sample, you will add a volume of 0.2% dithiothriotol, otherwise known as DTT, that is equal to the same volume you previously removed from the master sample. Following the addition of the DTT, you will pipette aspirate the sample up and down several times to ensure adequate mixing. Following that, you will put the sample on a rotating tumbler for 15 minutes.
Get a picture, get an angle on this side. Scoot back. Hold on. Move. Because I'm trying to get it flush. Go above it and get a picture of like this cone. Okay.
Following homogenization, the sample is filtered through a pre-wetted 48 to 53 micron nylon mesh filter into a brand new 50 ml tube. The sample filtrate is spun at 790 G for 10 minutes. Remove and store the entire volume of the DTT containing supernatant and store it at -80 degrees Celsius. Do this in 2 tubes. Remove the entire contents of the supernatant and divide it into 2 equal aliquots. Store at -80 degrees Celsius. After the supernatant is removed, you will resuspend the cell pellet in 0.25 to 2 mLs of cold DPBS depending on the thickness of the pellet. In this case, we'll be adding a half a mil of buffer to the cell pellet. Next step is for cell counting. First, take 10 microliters of the cell suspension and add it to 10 microliters of trypan blue stain. Mix that up and down several times. Next, on the hemocytometer, take 10 microliters of the sample, inject it into one of the ports so that it's adequately saturated. Put the hemocytometer on the microscope stage Use the 40x objective and begin counting both live and dead cells. Include the squamous epithelial cells as well. Do not include red blood cells. During the counting, you will count all 4 corner quadrants of the hemocytometer. Your counting should be done in a consistent pattern, starting from the left and proceeding to the right, dropping down 1 row, then right to left, drop down 1 row, then left to right. Use this same pattern in all 4 corner quadrants. Again, count both live and dead cells, as well as enumerate the squamous epithelial cells. After you've finished your counting on the microscope, you'll fill in the table with your cell counts. Again, remember to include both the dead and live cells, as well as the squamous epithelial cells. Once you have those numbers recorded, you can perform the total cell count and the cell viability. Total cell count is performed by taking the sum of the 4 grids, dividing that number by 4, multiplying that by 2, and then multiplying that by 10,000. Once you have that number, you will multiply that by the volume of the sample. Determine the total number of cells per gram of sample by dividing the total cell count by the weight of the processed sample from earlier in the procedure. The viability is determined by dividing the total number of live cells by the total number of live plus dead cells times 100. To make cytospins, the sample needs to be at a concentration between 500,000 to 1,000,000 cells per mil. Load the cytospin by putting 60 microliters of cell suspension into one setup. You will make a total of 4 cytospin slides, if possible. The first slide you can use 60 microliters, the second slide you can use 70 microliters, the third 80, and the fourth 90 microliters. Each of those slides are entered into the cytospin centrifuge. After the 4 slides are removed from the cytocentrifuge, they will be fixed in 95% methanol for 10 minutes. Following fixation, the slides are allowed to air dry at room temperature for 10 minutes. The last step in the process is to prepare the cells for the extraction of RNA. From the remaining cell suspension, spin that sample down at 790 G for 10 minutes. Following centrifugation, remove the total supernatant and discard it. To the cell pellet, you will add 500 microliters of cold DPBS and 500 microliters of Zymo Research RNA DNA Shield. This 1 ml volume will be distributed in 2 half ml aliquots for storage. These 2 samples will be stored at -80 degrees Celsius.